Hello class, this is Mr. Lehman. I want to do a limiting reactant problem with you today, a special type of stoichiometry problem. Alright, so let's do a combustion problem. And so this is a review of our process. We're going to do a mass-to-mass limiting reactant problem. So we're going to take the mass of one reactant, divided by the molar mass to convert into moles. We're going to multiply it by the ratio, how many of the product we can make from how many of the one reactant to find out moles of product, the unknown, and then we're going to multiply it by the molar mass of the product to figure out how much of that product can be made. But we got to do that two separate times. We have to do it for each reactant. We're not going to be given which one is in excess, and so we got to figure out which one runs out first and which one limits our reaction. So that's what we're going to do. So let's use the combustion of propane. So propane will react with oxygen to make CO2 and water. And we can balance this with those coefficients. 10 oxygens here, 6 oxygens, 4 oxygens, so the 6 plus 4 is 10. So we need 5 pairs of oxygen, not 3, not 4. Oops, wrong button. So here's what we're going to do. So we're going to say we have 30 grams of oxygen available to us, and we're going to say that we have, let's just say 30 grams of propane available to us. In our job, we're worried about global warming, how much CO2 we're going to produce. So how much CO2 can we produce by reacting these amounts of reactants? And we're not worried about water. It's a byproduct. It's not mentioned in our questions, so we'll just eliminate it from our view by putting a little check through it. Alright, so pick either reactant. I'm going to do 30 grams of propane, and I'm going to try to figure out 30 grams of propane can make how many grams of product. Then, through a separate calculation, I have to take the other reactant, oxygen, take 30 grams of oxygen, and figure out how much CO2 I can make. Alright, so let's do propane first. Alright, so 30 grams of propane, we can find out that 1 mole of propane is 44.11 grams. So it's 3 carbons at 12.01 apiece times, or plus 8 hydrogens at 1.01 apiece. And then the ratio, this is my known, this is my unknown, so we have 3 moles of CO2 produced for every 1 mole of propane. And then we have to multiply by the molar mass of our unknown, our product. And so 1 mole of CO2 is 12.01 plus 2 oxygens, 32, so it'd be 44.01 grams. Alright, check, make sure everything cancels. Grams cancel, moles of propane cancel, moles of product cancel. So I'm going to go ahead and crunch some numbers. I suggest you do the same. The 30 divided by 44.11 times 3 times 44.01 equals, we get 89.795. So 795 will round up to 0.80. So this is how many grams of CO2 we can make by combusting this much propane. So we're going to do the same thing. 30 grams of oxygen can make how much CO2? And I'll use blue for this to show you the blue pathway, the second pathway. Let me scroll. Alright, so 30 grams of oxygen, put that over 1. 1 mole of oxygen, 2 times 16 is 32 grams. The ratio is 5 to 3. The 3 is the unknown, so the 3 moles of CO2 go on top. What we start with goes on the bottom, so 3 over 5, not 5 over 3. And then same step as last, we're going to multiply by 44.01 grams per 1 mole of CO2. Alright, so if we take 30 divided by 32 times 3 divided by 5 times 44.01, we get 24 24.76 grams of CO2. So I have enough propane to make 89.80 grams of CO2, but I only have enough oxygen to make 24.76 grams of CO2. So the last step of the limiting reactant problem is you pick the one that is the smallest amount. So if I only have enough oxygen to make 24.76 grams of CO2, then once I make 24.76 grams of CO2, the oxygen is gone, I have no more oxygen left, and I can't make any more CO2s. So that is it. You pick the lowest number, the lowest answer, and that is it. So we're going to learn in the next tutorial how to figure out how much of the excess reactant you have left over. I hope this helps.